Shwetak Patel has conclusively answered the rhetorical question, if walls could talk. This University of Washington professor has figured out how to listen to our electrical outlets and pipes, and they have a lot to say about how we consume our utilities. It's cheap, accessible technology that has won this young scientist so many accolades. He's a MacArthur Foundation genius, Seattle's most influential, and he inspired a Wired magazine cover story. He even sold his first company to Belkin while he was still in grad school, which is why Shwetak Patel joins our exclusive list of the innovators. I'm Hanson Hossein. Welcome to Four Peaks. Well, Shwetak Patel, welcome to Four Peaks.
Thanks.
So the thing that most astounded me about you, and there's a lot to astound, is that you are actually a licensed plumber and electrician.
Yeah, sort of, actually.
Do you have to actually have that expertise to accomplish what you've accomplished?
Well, not really, but I think I pull from that as a way to beef up the research in a way, because some of the things that we install in the electrical system or in the plumbing system, you kind of need to know a little bit about the electricity and plumbing, and sometimes it's actually illegal to install some of these technologies without being a plumber or electrician.
So what came first, the innovation or the license?
The license.
So, and when did that actually happen?
Oh, that was a long time ago. I think I was an undergrad. I went to school at Georgia Tech. And so in Atlanta, they have this program called Habitat for Humanity, which is actually a national program. And so I didn't want to just paint the walls and just help with the drywall and stuff like that. I wanted to work on the infrastructure, but you have to actually be certified to work on the electrical and plumbing infrastructure. It's like, oh, I can do that. Turns out it's not that easy. but I ended up getting trained and I learned how to do the trade.
So how much did that learning of the trade actually feed into the research that led to the products?
Yeah, a little bit. I mean, so even though we had this idea that we were going to build this technology to reduce energy consumption, water consumption, and I actually used a lot of that knowledge because it informed the design of these research projects. So it helped a lot, actually.
That's amazing.
Yeah.
And what I really love about the innovation is that it's actually a really simple idea. This could have been a very complicated thing with putting sensors all over the house.
That's right.
But you fundamentally recognized that there was a unique noise signature to every appliance.
Yeah, that's right. Yeah. And it's traditionally how computer scientists have solved this problem is you would put a sensor behind every appliance, every water fixture, and that could work, but it doesn't scale. And so what we said was, let's try to figure this problem out by using a very small number of sensors, maybe one or two sensors, and make this into a machine learning or an artificial intelligence problem where from a few sensors, can we use software to figure out, well, what's happening? And what we figured out was that every appliance, every water fixture has its own little signature, and that's what we're using.
And this signature is it a sound?
Well, there's a couple of things. It's a electrical property. So one thing you can imagine is when you turn on a light bulb, incandescent light bulb is about 100 watts, and so when you turn that light bulb on, it consumes 100 watts. But you might turn your dryer on, that might be 2,000 watts. And so just the power profile tells you a lot. But that's not enough. So if you have a light bulb and a laptop, they may actually be very similar. It might be 100 watts each. So we need even more information. And so it turns out that all of these electronic devices propagate electromagnetic interference back over the power line. So a good example is you may have your cell phone next to your speaker and you might hear that buzzing. That's a good example of that. That's EMI noise coupling back into the infrastructure. And that noise tells you a lot about what kind of device it is.
So what happens if you have two light bulbs in the same room, though, the same wattage? How are they different?
So let's say you have a complex fluorescent light bulb, so a modern CFL. So even though they have the same wattage, it turns out that each one, even though they might have the same kind of EMI noise, the electronic tolerances are actually different enough. So the capacitor, the resistor, all these little electronic components have 5 to 10% tolerances. So which means that they're not exactly the same. They're just different enough that you can tease them apart.
That's incredible. So what does this technology look like for the consumer? I'm just playing a little video of what you've got here.
Yeah, so as people are using different appliances and devices in their home, you can actually get a breakdown of this energy use. So the technology is actually pretty simple. You just need one device that plugs into an electrical outlet. You need one water sensor that screws onto any hose bib or any appliance, and you just need one of them. And all this is basically showing you the breakdown of different devices in your home. So the laptop was just turned off and turned on. You can see it change. When you turn on the TV, you can immediately see that change that happens. But the other thing is it gives you a breakdown. It's almost like a little a credit card receipt. It tells you what percentage or how much you are consuming for each device or appliance in your home. So typically you just get the aggregate number when you pay your bill at the end of the month. Here it's going to give you a breakdown. So
and you can monitor this from home or from your office
right.
or halfway around the world,
this is all in the cloud. So you can use your iPhone, iPad, you can use any kind of mobile device to look at it.
So I get how the electricity part works. How do you actually get the pipes to talk to you?
Yeah, so the pipe there's a simple analogy. When you teach people about electronics, you often talk about the metaphor of the pipe system. And so looking at, in the electricity space, we're looking at, electrical noise. There's actually water noise or pressure noise. People call this water hammer. So every now and then you may actually hear your pipes banging or reverberating when you flush the toilet or take a shower. We're actually looking at the minute water fluctuations that tell you a lot about what kind of fixture was used. Was it a toilet? Was it a washing machine? Was it a sink?
Why it seems so simple now that you've explained it to me. Why didn't somebody think about this earlier?
Well, one of the things that we're looking at is actually noise. So electromagnetic interference, that's noise, pressure noise. And people don't really care about that.
It's kind of waste or exhaust, right?
Exactly. So people have spent a lot of time trying to thwart or reduce or remove noise. So what we've said is, let's turn the research on its head a little bit and take advantage of the noise. And so that's kind of a good theme of our research, is we look at these problems from a very different perspective and come up with solutions that are kind of off the wall.
It's funny because we talk about the signal to noise ratio. In this instance, the noise is the signal.
Yeah, exactly. In fact, I give many talks around the country that is entitled, "Your Noise is My Signal."
and from a consumer point of view, how much does this product cost? Where can they get it?
So we spun out a company years back called Zensi, and that company actually got acquired by Belkin before we even closed our A round of VC funding. It was one of the first successful exits in the clean tech space, and it was really exciting. And so Belkin is now commercializing and pushing the technology out. They just recently released a press release on the technology for both electricity and water. So they're going through utilities to make it available, and they're going to make a consumer electronics product as well down the road. And so the idea of this is making it pretty cheap, maybe a few video games worth. And it will pay for itself within a short period of time.
So the product itself is not, you can't buy it off the shelf right now, but it soon will be there.
Exactly.
And do you know how much it might cost?
The idea is to be maybe a couple video games, so maybe like $100, maybe something like that. But right now it's going through the utilities, so the utilities are going to be making this available to consumers. And so right now there's pilots around the country where it's already deployed to utilities.
And do you still have a relationship with Belkin?
Yes, I do. So I work with their Chief Technology Officer and CEO for both the direction of their company in terms of energy monitoring and sustainability products, but also help them with the next generation products in the space.
Well, it sounds like life-changing technology. And when we come back after the break, I want to talk a bit about how your timing was impeccable. We'll be right back with Shwetak Patel. We're back with University of Washington researcher Shwetak Patel. Shwetak, this work is amazing. It's obviously going to change our lives. It seems to me that it's incredibly accessible as well. Why is it so possible now for this to happen?
Yeah, I mean, I think a part of it is because of the research philosophy that we employ. So one of the things that we focus on is not just the basic science, but also the applications of computing technology. And so when we try to go solve a problem, we're actually solving it from an applications perspective. And so when we have these breakthroughs, it's already really close to the consumers because it's inherently applications driven. And so, so our focus is to have an impact soon. And maybe there'll be technology down the road that's going to be better, but you can't really understand the future until you invent it now. And so we want to make it available as soon as possible. And so we're solving these problems in such a way that we can do it.
I mean, and you say applications driven. I mean, 10 years ago, a consumer would not have understood an application, right? It's now thanks to these mobile devices that we're literate in this. So we've got this. We understand how to use this. You were talking about sensors and big data, machine learning. That's all part of your research. That's all of a sudden now hit critical mass, hasn't it?
Yeah, that's right. Yeah, sensors are getting cheaper. Devices are getting cheaper. I mean, the phone that you're holding right now is the computer of 3 years ago, and it's in your pocket. Computing technology is getting to a point where sensors are smaller, lower power. Power is starting to become an issue, but at this point, they're becoming so low power that it can run for a day on a single battery. And so I think we're at a point where we're getting more and more data. Data's coming out much faster than we could actually process it. And so there's a unique opportunity for machine learning to make sense of this data because we can't digest it ourselves.
And so part of your work is also in coming up with the algorithms for the machine learning to occur, right?
Yeah.
And so the big data, all of these things, I mean, how accessible is that to all of us? Do I have to be a PhD like you to figure this out?
Not really. I mean, there's a couple of different ways to look at it. I mean, you don't have to be a computer scientist to understand big data. There's lots of tools that are coming out to make it easier to approach, to help you sift through the data. And so I think there's opportunities to leverage the big data technology to make it easier for you to understand the information.
What I find so compelling about everything you've done is that this is fundamentally about listening.
Yeah.
And finding sort of the wheat and the chaff actually has value. So you've looked at energy, you looked at water, electricity. There's also health benefits and applications with something like this, isn't there?
Yeah, that's right. You know, what we're trying to do is try to push the sensing technology as far as we can and try to solve everything as much as we can in software. So one of the things we've been doing is let's take the mobile phone, use the sensors that it already has, and can we turn it into a health monitoring device? And so one thing we've done is we've created an application that you install on the phone that actually can turn your phone into a spirometer. So a spirometer is a device that assesses lung function. So if you have COPD, cystic fibrosis, or chronic asthma, people know what a spirometer is. You blow into this device, it gives you an evaluation of your lung function. Problem is, if you want to do this at home, you got to buy this really expensive device, you got to carry it around. But we actually said, let's solve the hardest problem, which is, can we build a piece of software on the phone that requires no additional attachment to it? And that's what we did. Hold the phone arm's reach away, you blow at it, and it gives you the same kind of assessment that a clinical spirometer can give you at your physician's office.
But it's not actually using my breath, it's actually listening to my breath.
That's right,
Yeah.
yeah.
It's the microphone in the phone.
Yeah, the microphone is the sensor in this case. And what we're doing is we're actually using speech recognition technology to listen to the amount of air coming out, if it's obstructed, if there's some restriction there, if it's normally coming out. And so we're using signal processing to basically turn your whole body into a flow sensor. So you don't need to have anything in your mouth.
So I know you're in your 30s. I am not, but I was a huge Star Trek fan when I was a kid. This sounds like I'm landing on a new planet, and I take up my tricorder, and I'm listening.
Yeah.
Is this the same idea?
It's amazing that you just bring that up. I've had 4 meetings today, and the tricorder analogy has come up 3 times today. Right? I mean, yeah, that's the next generation. I mean, this technology is going to be able to do a lot more things than just be a telephony device. It's going to allow you to use it for tracking, personal, calendaring, for health technology. But most applications in general are going to be on your phone now.
It seems like you can hear or listen to anything thanks to this technology. What are some of the constraints that we can't use this kind of listening for?
Yeah, I mean, you inherently, so this is a very indirect technology, right? So if you want to, sense something very specific, let's say you're in a home, if you want to detect if a particular leak is happening or if a particular device is failing, well, this is a very indirect technique, so you can't really get at that. So there's going to be some needs for direct sensing technologies, and my lab's been working on that as well. The challenge there is if you have 1,000 sensors in the home, how are you going to replace the batteries? So we've been working on ways that you can get the power down so much that on a little hearing aid battery, it'll last 25, 30, 50 years, so you don't have to worry about the battery. So that's another innovation space that we're pushing on.
Great. Well, we're going to take a break, and when we come back, I want to talk a little bit more about the implications of this technology, of this so-called Internet of Things, as it invades all of our lives. So after the break, we'll have more with Shwetak Patel. We're back with Shwetak Patel from the University of Washington. Well, this all sounds amazing. It sounds like the future is now, Shwetak. I imagine as people look at this or they hear what you have to say, it's like, well, that's great, but do I really want my utilities to know that much about what I'm using, when I'm using, how I'm using it? There seems to be some privacy concerns about that data. Yeah.
No, we're in a generation where we have more and more technology out there, and we're getting more and more information about our daily lives. And I think that's a valid concern. One of the things that we're doing to address this is, when the algorithms are running, that you get the data back. So the consumer gets the data back. So when the utility is using this information, they get it as an aggregate. And so we have some mechanisms in place that the consumer is looking at their own breakdown. The utility mainly sees it as an aggregate information, so at a block level or at a city level.
So not personalized at all then.
Right. We try to depersonalize it. And plus the infrastructure that we've set up is very similar to a banking infrastructure. So we have the same security mechanisms there. So people do online banking. People use something like mint.com, right, where they aggregate it for you. So that kind of trust is built there because there's a security infrastructure set up. We're using the same security mechanisms. The other thing is that it's also the privacy is definitely dependent on the value add there. So if people really value what you're getting back from it, then the privacy concerns may be mitigated.
It's the same value proposition that Facebook and Google give us as well, right?
That's right.
You give us your data for free, and we'll give you something back for free.
Yeah,
and that's
exactly.
how it works out. And people generally want to do that.
Yeah.
It sounds to me that this is fundamentally about behavioral change.
Yes.
That if people start to see how their minute actions actually have consequences, that they're going to possibly change how they consume, essentially.
That's right. So in a way, the controllers are the humans, right? You could actually add a switch to your house that turns things on and off, but the behavior is what we're really going after. Part of the reason is a lot of the energy use in your home is kind of out of sight, right? People think, if you ask somebody what are their big consumers, they'll say, oh, it's my lighting, or it's my dishwasher, or it's my oven that I use. People don't use their oven that often. It turns out it's the little DVR that's running all the time.
It's called that vampire
power, right?
Yeah.
The digital video recorder has a hard drive spinning all the time. I mean, we show people their data all the time, and they don't realize it's the thing that they don't see. It's the thing that are out of sight that are the big consumers. So it's a way to educate them about what's really going on in their home.
So out of sight, out of mind, which which isn't great. But on the other hand, you mentioned like this could look like a credit card statement, and we don't like getting credit card statements because it really shows and itemizes every single expenditure.
Right.
Do we really want to start being super conscious about everything that we get on?
That's right. And so we've been sensitive to that. So some of the things that we work on is how do you actually effectively feed this information back to consumers. So the itemized receipt might be on the back of your bill, but on the front might be more actionable information. Here are the top 4 consumers in your home. Here's some things that you can do to really make a difference. So make it actionable, make it approachable. Don't give people a laundry list. The laundry list is there if you want to dig deeper. So what we've done is the feedback is done in such a way that it's approachable.
Have you thought about gamifying some of this and making it a game, and sort of putting challenges down?
That could be interesting. Some of the there's undergrads at UW that want to make competitions between their dorms, right? Use this technology to say, look, we're more eco-friendly, or we're using less water or less electricity. So I think you can do that. And one of the things that we've been doing with Belkin is some of the bills actually show not only your consumption, but the average consumption of your neighbors with similar appliances. So is it just you? Is it the appliance that's failing? So that kind of gives you a little bit of context.
So as this technology truly rolls out and it becomes ubiquitous, essentially.
Yeah.
How do you think our lives will change? Like 5-10 years from now, what are things going to look like?
Yeah, I think this is going to be an interesting kind of change in terms of how you interact with your home or your daily life. We're trying to figure out ways that we can reduce the overhead in terms of these little things that we don't want to, these chores that we have to do that we don't want to deal with. But I think computing technology is going to help us make that easier for us. We'll get suggestions, recommendations, we'll get warnings, and that's what we'll rely on. And basically, our daily lives, we can focus on what we think is fun, right? And so I think this data is going to get aggregated to a point where I think the privacy concerns will be there, but I think the value add is going to be more than the privacy concerns.
So it sounds a little bit invasive, but I think it's basically, we say that this is kind of the culture that we're used to, but we might get used to this at some point.
Yeah,
right?
I think so, and I think we'll be able to glean information that we weren't able to do in the past. Warn you that your water heater is going to leak 10 days before it even leaks, right? So you don't have to worry about that very stressful situation.
It sounds like the Jetsons are finally upon us. It's a brave new world. That is perfect. Well, I know that you're originally from Selma, Alabama, and I want to talk a bit more about how geography has played into your innovation, especially here in Seattle, when we come back to you after the break.
Okay.
So we'll have more with Shwetak Patel. We'll be right back.
Four Peaks is made possible by generous support from the Museum of History and Industry and from Weber Shandwick.
We're back with inventor Shwetak Patel, who's going to be changing all of our lives very soon. So you were born in Selma, Alabama, which is not something that people would never really associate with somebody who's bringing these kind of technologies to the world. Yeah. How did that sense of place and your upbringing in that part of the world play into how you see things now?
Yeah, it was an interesting it was an interesting time. I didn't think much of it because my parents are immigrants from India, so they moved to the U.S. a little over 30 years ago, and I was born in the U.S. And so my kind of view on the world was actually fairly broad. I had Indian I grew up in an Indian family, but my friends were Americans, right? And so it was an interesting opportunity to kind of broaden my outlook on how what different cultures are, right, and how the world is really set up. So I got lucky in that regard, and my parents were very supportive in letting me explore.
And why did you decide to plant your flag here in Seattle, University of Washington?
Yeah, so when I graduated from Georgia Tech with my PhD, I looked around the country and applied for faculty positions, and I was lucky and got a number of faculty positions. In fact, my wife is also a computer scientist, and so we're actually both professors, and so we were lucky and found two faculty opportunities at a number of different places. But it felt like the University of Washington was a great place for us in terms of not just regionally, because we love the Pacific Northwest, we're outdoorsy, we love the region itself, but the computer science program and even the electrical engineering program is a top department. And the other thing is industry. The industry nearby is actually very critical for the kind of work we do. So Microsoft Research is very critical in the kind of work we do. There's Amazon, there's Boeing, there's also Google, and so that nucleus is critical for the kind of work we do. And so this was the best ecosystem for our work. And
speaking of ecosystem, the impact of your work, whether it's on the sort of the house sensor side, that's got environmental implications, and on the health side, and that's also what happens here. Yeah. How much does that sort of that green technology play into this?
No,
as well?
I mean it makes a big difference. And when we were doing some of the water work, the HydroSense technology, we were working with the local utilities, and some of the best minds are actually here in terms of conservation. Those people are here, so we're lucky in that regard. We have PNNL, Pacific Northwest National Labs, which are nearby, and the med school. One of the best med schools in the country is at the University of Washington. So I mean, you just walk across the street, I get to collaborate with the best med school, and so I think that played a huge role, and that's playing a significant role right now.
So you sold your first company to Belkin. Now you've got another company here, right? And what is that about?
Yeah, so the new company is called Snoopy, and this is a really interesting opportunity to kind of expand the technology out. So I mentioned how, sometimes you can't sense everything indirectly. You've got to have a direct sensor. So the idea here is let's build sensors that are small, low power, that you can sprinkle in crawl spaces, attics, behind walls, but they're so low power that you never have to worry about replacing the battery. The analogy I like to talk about is people take their little battery out of their smoke detector because it's annoying them, it's chirping, but they forget to put it back in, right? But here, you never have to worry about the battery. And they're going to monitor things like leaks, humidity, mold, and give you information without you even having to touch the sensor.
So how far away is this future?
This is getting pretty close. I mean, the startup is moving fast, and we'll have a product pretty soon where we'll start doing some simple sensing some simple things in the home and expand from there.
Well, it looks like you're going to be changing all of our lives very soon. I think I look forward to it. So Shwetak Patel, inventor and University of Washington professor, thanks for joining us. And we invite you all to extend your reach by connecting with us at 4peaks.org. I'm Hanson Hossein.
Production of 4 Peaks would not be possible without the generous support of our sponsors.